Okay. So what are the strengths? Let's start with the good stuff. So yesterday, Matt began to mention some of this stuff, right? A huge strength is that digital trace data is very large, right? So here we have this graph of information storage. This is only taking us up to 2007. But in 2012, the amount of information collected, the amount of data collected in 2011 alone was the same as all data collected in all previous years of human history combined. And I think the last data points I've read on this suggest we're surpassing that even more rapidly each month. So that's exciting. Now, to put some cool water on that, much of that is, say, pixel data, data that's not necessarily measuring important social processes. But I think we could all agree that thanks to the increasing size of data and increases in computing power, which have allowed us to both collect it and analyze it, we're in a much better position as social scientists to look at large-scale processes. And in some of Duncan's earlier work, he signaled one of the most promising potentials of this work was that we could maybe look at population-level processes, right? That we are typically in the business of taking a random sample from a population and trying to understand the population. And that if we really do have data about a whole social space, and that whole is key, right? It's not everything. So we might have a population of Twitter users, and as we'll see as we get more into the data today, this is emphatically not representative of many or even most offline groups, right? But if our goal is to generalize to that online community, then we have a population level sample in many cases, which is really exciting. Second, these data are always on. So, very often as social scientists, we're in the business of making a survey, and we have to predefine what we want to measure. So we have to know what kind of questions we want to ask, what kind of people to answer a question, right? And a huge virtue of digital trace data is that they're always being collected, they're always on. And as a result, we can very often work backwards and collect data on the kind of more stochastic elements of life, right? Things like the Tahrir Square protests pictured here, right? Where we're able to kind of go back and have data points. Now, what those data points mean is going to be, again, a very important thing we need to think about. But we can recognize the stochastic nature of so many social processes and capture these, particularly these unexpected or even unprecedented events, such as the Arab Spring. Third, digital trace data are non-reactive. So very often when we're collecting, say, a conventional survey, we worry about things like social desirability bias. So for example, if we want to measure here self-induced abortion, and we were to do a study of self-induced abortion, right? The survey, we might worry, would have a significant amount of social desirability bias, right? Nobody wants to discuss that issue before a survey researcher who they have no previous experience with it, right? Or similarly, in other work, I've used Google search data, which is pictured here. These are searches for self-induced abortion in the US to track things like violent radicalization. So people who might become violent radicals might Google something like how to join ISIS, right? Not very intelligent people, of course, but these people would be unlikely to announce themselves as violent radicals before a survey researcher, right? So another huge advantage of digital trace data is that they're kind of naturally occurring, right? They don't result from the intervention of a researcher, right? And that's kind of a bug and a feature, because if we were making Michelangelo, right, if we were building up a study from the ground up, we like to be able to define all the parameters. We like to be able to define all our questions clearly. But when we do that, right, we have to engage subjects, human subjects, and that creates, in many cases, a serious amount of bias. Okay. This is another important one. Captures social relationships. So, we very often, many of our theories, especially those of us who are interested in social networks, right? We often want to test theories about social relationships, not about individual attributes, but about how people are connected to each other. And if we do this in the context of a traditional survey, right? If we want to build the network of the people in this room, we'd have to administer a survey to everyone, ask them to describe everyone they know, right? And this would be a very, very greedy or very time-consuming process, right? We would have to ask a lot of people a lot of questions. And even then, we'd face some important problems that a social network or a researcher might call the boundary problem, right? So where do we stop doing that sampling process, right? All of you are probably connected to people outside this room and share kind of a second-degree connection with each other. That would be really tough to pick up. We'd have to interview untold numbers of people to really map the whole population. Again, in these online settings that we may be interested in studying, so here is the European Parliament members' Twitter networks, exciting group of people that they are. That got a laugh from the Europeans. We can actually start to see clusters of social relationships. And that has immense value in a field where so many of us are interested in the science of social relationships. How our relationships to each other are predictive of things like the spread of information, the spread of disease, who gets a good job, you name it, right? So the strengths are big data are big, non-reactive, they capture social relationships, and they're always on, right? And those are big strengths, right? We don't want to forget that there's a lot of good that can be done from these types of data alone, but they have so many weaknesses. And I think, early on in the field of computational social science, this was not yet well known. We still had many people kind of celebrating and touting the strengths of big data, right? As Matt mentioned yesterday, we had people saying, we no longer need theory, right? Because we have data now, right? And now many of us, can look back on that as something extremely silly to say, right? If anything, we need more theory. And so we can imagine many of the weaknesses. Bit by bit, Matt's book has a good discussion of this, and I'll draw from that and add a few of my own. So first, it's just that these data are incomplete, right? So earlier I mentioned that big data are always on, that they are non-reactive, but let's say we wanted to do a study of, say, harassment in some kind of online setting, right? We would soon discover, right, hopefully, that many comments that we might be interested in measuring as a key outcome in our study of abusive behavior in some kind of online setting might be removed by the modifier, the moderator, right? And so big data are very often incomplete, right? This idea that big data is capturing everything, that it's always on and capturing everything. Now don't get me wrong, there are sources of data out there such as Google takeout data. If we do the thought experiment, right? If Google has every Gmail we sent, every web search we ever made, every Google Maps step we ever took, every YouTube video we ever viewed, right? Which they do, right? That's an immense amount of information that in theory could be used to trace social processes with unprecedented detail. But of course, we can't access that data for good reasons, right? So big data are very often incomplete, even though we might want them to be representative. And much of the early work in our field kind of assumed that this data, again, we're going to somehow displace conventional survey data, right? Set expectations sky high, right? That if the data didn't answer all the world's questions, then they were junk, right? And so now we're running into situations like this. We're realizing that big data can be very incomplete. And as I just mentioned, big data are very often inaccessible. So a good example is Facebook, right? Many of us have research questions that could be very interesting to examine with Facebook data. And though large chunks of Facebook are in the public domain, Facebook fan pages, and so on, the vast majority of Facebook is off limits to us researchers unless we obtain permission to access data from users or collaborate with industry, right? And this goes for, of course, sites vary, right? Twitter is fairly open. It's perhaps why it's become such a locus of research in our field, because it's fairly straightforward to get Twitter data. But on the other hand, other sites such as the aforementioned Google Takeout data, right, which is all that Google data packaged together, right? Just like as you download your Facebook account, you can see all of the information you've ever produced. You can do the same with Google. And we heard last year from a researcher who built a pipeline to analyze Google Takeout data in a very creative manner that allowed them to kind of analyze these data without ever downloading them onto their servers. That was work by Deborah Estrin. You can check that out on the archive videos from last year if you're interested. Okay, so they are not accessible. They're also not representative, right? And this kind of dovetails with the incomplete issue as well, right? So we can see here, these are just some simple racial demographics. This is from an older Pew study. This has changed a little bit. But if we're looking at the national or US population, and by the way, these figures vary tremendously across countries. If we were looking at Turkey, for example, Twitter has extraordinarily good coverage in Turkey. But if we're looking at the US, parochial as we may be, we can see even in our own top 3 or 4 social media sites, pretty significant, in this case, racial and ethnic differences in who's using which platform. And so if we go through and say, want to make claims about attitudes about race using Twitter data, right? Or if we want to really pick your topic, right? That has that's influenced to some degree by one's racial and ethnic identity, right? We have huge issues around our sample, right? We can't take Twitter data as representative of the entire public if it has a larger share of the, for example, the Black and non-Hispanic population than other platforms. Now we can there's some new promising directions, some of which Matt will talk about on Thursday, I think, such as post-estimation weighting, where we can start to try to tease out some of these things. But anyone who's just going to try to do a study that is inattentive to the non-representativeness of social media data, right, is going to get into serious trouble with reviewers or anyone else who's now familiar with these type of dynamics. MySpace. This is where I show my age. Who is on MySpace? Matt, okay. But there's it gets worse every year. Okay, so MySpace, for those of you who don't know, was kind of the original social media site. It was really the thing for, I don't know, a year there, maybe a year. Okay, so, and now nobody's heard about it, right? And so this is an example of what Matt, I think, nicely calls drift, right? That, all the time, all of these platforms are changing, right? If we're talking about digital trace data collected online, right? So the other joke I like to use with my undergrads is I say, well, how many of you are on Facebook? And they all raise their hand. And then I say, well, how many of you are on Instagram? And then they all raise their hand. And then I say, well, which one do you use more? And they say, well, Instagram, blah, blah. And I say, okay, well, why don't you use Facebook? And they say, well, because our parents are on Facebook, right? So there's these different groups of people are drifting on and off the platform. The platform itself is also changing over time, right? So they're becoming more widely used by different types of people, more or less widely used. And so in the case of MySpace, an early study of MySpace that then, say, wanted to generalize to some future social media site has this obvious issue, right? That the platforms are always changing. And today, just to add an aside, we have an additional, perhaps even more daunting problem, which came up in some of the discussion of Duncan's work last night, which is that things are spreading across platforms all the time, right? And there's very little research on cross-platform spread in the exchange of even just simple things, relatively simple things like the spread of information across platforms. Algorithmic confounding. This is a plot from a paper by David Lazar, Gary King, and some other co-authors. David Lazar will be visiting us tomorrow night and giving a speech And this is a really nice paper. It takes the Google Flu data. Google Flu was a tool that was developed by Google Labs some years ago. And what happened is Google data scientists recognized that they could track the spread of influenza very well with Google search data, or so they thought, right? And so what we see up here in this top panel is in the orange is the Google Flu estimate of the prevalence of influenza over time for about 2 years. And then in this blue line here is the estimate from the Centers for Disease Control, which is the body of the US government responsible for tracking disease, right? And then we have some lags in here too. And what we see is for 2 years, there's really great tracking. Google Flu is really just nailing it. And then one day or 1 month in late 2012, the Google Flu estimates started outpacing the CDC estimates by more than double, right? And so this caused great concern, right? Is there a major influenza outbreak that we've all been worried about for many years? Or was there something wrong with the data? And so in this paper, Lazar et al. Kind of go through and try to do a postmortem or a diagnosis of what happened, and discovered that this increase was likely the result of what they call blue team dynamics, or the tendency for some property of the social media platform to change users' interaction with the platform, which then becomes interpreted as some kind of meaningful signal about social behavior, right? So in this case, people who were searching for symptoms of the common cold then saw an ad about, say, the flu, and then started Googling things about the flu. And so these are very, very major problems, and there are, one of the most daunting things about this problem is much of the information about algorithmic confounding is not in the public domain. Just a few more. Big data, digital trace data, they're messy. Again, I think people like to think of digital data as being inherently clean, but especially because so much of the data we're working with is text data, right? It's unstructured. It's not the neat zeros and ones we might like to see in a CSV file to run our models on, right? And so we really have to do a lot of work data cleaning. In fact, a survey by the New York Times about 4 years ago of data scientists suggested that most of them spend about 80% of their time data cleaning and only about 10 to 20% of their time actually running models. And I'm seeing heads nod around the room. Many of you have had this experience. I certainly have, yeah. Sensitive, right? This is a huge one. Here, this was several years ago. A North European researcher caused an uproar by publishing data that he had scraped from some 70,000 OkCupid users, right? Now, we're going to talk about all the kind of reasons not to do this shortly when we talk about screen scraping. But it's worth noting because this wasn't even a case where there was some kind of accidental disclosure of information, which is another genre of sensitive data issue that we need to be very careful about, say one that was exemplified in the Cambridge Analytica case, but one that just simply resulted from some people compiling data that was available on the internet into one large database, and that merging, even of metadata, seemingly innocuous metadata, as Lazar shows in a new paper, can actually lead to identification of individuals. So we need to worry about that. Finally, there's some kind of a lead or publication bias in a lot of digital trace data, right? History is written by the victors, or just something like, people don't put everything out there about their lives on social media, right? And certainly there's positivity bias on something like Facebook, right? So here your Facebook posts make you seem really interesting, but remember, dear, there are people who know you in real life, right? Suggesting here that, if we want to, again, understand, say, emotional dynamics by looking at Facebook, we're probably missing a lot of important negative emotions, and certainly emotions such as shame, right? If there is indeed this type of positivity bias. So the future, again, I think, we're all starting to agree. This is the hype cycle that Matt mentioned, the Gartner hype cycle from Monday's intro lecture, right? Digital trace data has been on this wild ride, right? We had this moment when we were really starting to say crazy things like we don't need surveys anymore, we don't need theory anymore, right? And then a set of very underwhelming papers came out, right? That said, you know, now we understand the Arab Spring because we watched people tweet about it, right? Where were those people, right? Were they in Tahrir Square or were they in London tweeting about the event, right? We might be able to tease out some of that through some fancy techniques like geotagging, right? But were they writing in real time or were they responding to, say, the CNN message? And then if we're going to make these strong claims that Twitter discourse, say, caused a revolution, right? We have so many confounding factors, and then we didn't even touch on the representativeness issue, right? So really, these types of studies brought us into the trough of despair, right? And now today, and moving forward, we're going to try to get to the plateau of productivity. OK, any questions? We're about to get into the nitty-gritty of collecting digital trace data, but any questions or comments on what is digital trace data, strengths or weaknesses of digital trace data? Nothing, great, OK.